Well children, we are doing some numericals on principle of superposition, so let us continue with a little more. This question is saying that three equal charges are kept at the vertices of the square. Then calculate the net force experienced by the test charge capital Q placed at the remaining vertex of the square of side length A. So look, these are what three equal charges, identical charges Q1, Q2 and Q3. And this is where our test charge is. This capital Q is our test charge. It is kept at the vertex, at the vertices of a square having side length A. So this is what side length is considered A. Fine. So what will happen? This is asking that what should be, find the net force experienced by the test charge capital Q placed at the remaining vertex of the square of side length A. Okay, so first of all we'll check that this test charge Q1 will exert some force on this capital Q and it is directed this one, say it is equal to F1. Now F1 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Okay, so it is the value of the force that this charge Q1 is exerting on this capital Q and it is directed this way. Now in our case R is equal to A. R is equal to A, so this magnitude will turn out as 1 upon 4 pi epsilon naught QQ upon A square. Now exactly same way, because three identical charges were given, so Q1 is equal to Q2 equal to Q3 and say it is equal to small q in magnitude. Now this Q3 is also exerting some force on this capital Q and it is acting in this direction upward. It is acting in upward direction. Now because you see that the distance is same, the magnitude of the charge is same, distance is same, magnitude of charge is same, so F1 is numerically equal to F3 and that's what it is written here. F1 is numerically equal to F3 and both is equal to what? QQ upon A square. So okay, now we come back to the next thing. This charge Q2 is held at one of the corner and it is trying to repel out this capital Q charge. Q2 is also numerically equal to Q in magnitude. So if it is repelling, so what is the diagonal length of this square? It is equal to A root 2. A root 2. Fine. So F2 is equal to 1 upon 4 pi epsilon naught QQ upon A root 2 whole square. So this is the value of F2 here. This is the value of F2 here. Now what is the situation? We try to do it this way because if it is squared, so it becomes what? QQ upon 4 pi epsilon naught 2A square. Now this F2 we are planning to resolve in two components. This F2 is resolved in horizontal component also and in vertical component also. Okay, so whatever is horizontal component, that I'll say it is F2x. Whatever is vertical component, that I'll say it is F2y. Fine. So this angle is what? This angle is theta is equal to 45 degree. So F2x, this is equal to what? It is equal to this value. QQ upon 4 pi epsilon naught 2A square cos 45. So the component of this F2, along horizontal direction, it is equal to F2x cos 45. Cos 45 is what? It is 1 upon root 2. So this value becomes QQ upon 4 pi epsilon naught 2 root 2 into A square. Okay. Similarly, this F2 is resolved for this vertical component also. F2y. So F2y then becomes equal to what? F2y then becomes equal to this. Exactly same. Both are equal because this side it is F cos 45. So this side it is sin 45. So sin 45 is also equal to root 2, 1 upon root 2. So this F2y is equal to this and F2x is equal to this. This we have taken. Now I'll just erase this extra drawing to make you understand something more. Okay. Now I'll say after this entire analysis is done, let me just say what is net force that is acting along x-axis. So Rx is what? Net force along x-axis is, here we have got F2x and here we have got, so this total component of force along x-axis is F1 was already present, and the component of F2 along this direction is equal to F2x. So this is 2 added, because in the same direction, in case we are trying to add, so it is F1 plus F2x. So F1 value is here, F1 value is here, and F2x value we have calculated here. So these two terms are kept here, and then the resultant force along x-axis we have calculated at this much. Similarly, in case we try to find out what is the resultant along y-axis, so this will be also numerically same. Why? Because the same component of F2 persists along this F3 also. So this F resultant force along x-axis is equal to resultant force along y-axis, and this is equal to what? Once you take this term common out of these two, then you find it is 1 plus 1 upon 2 root 2. Okay, now this is the resultant force along x-axis and y-axis, both we have seen. Now because these two forces are acting at 90-degree angle, so resultant force is what? It is under root FRX square plus under root FRY square. So if you just square and then add, so you will find that this entire term multiplied by what? Root 2 will come. So this is what it is, the magnitude of resultant force that this test charge capital Q is experiencing, that this capital Q is experiencing. It is the net force. And direction, you notice, because it was symmetrically placed, so direction is what? At 45-degree angle, at 45-degree angle with respect to x-axis. So it is very important question. Now let us look up the similar type of the question is there that has been many of the times in MCQ, competitive examination and board exams as well. 4 charges equal to minus q in magnitude are placed at the 4 corners of the square, and the charge small q, it is a test charge, at its center. You want to put the system in equilibrium. If the system you want to be in equilibrium, what should be the value of small q? Fine. So look, 4 charges, each of magnitude minus q, minus q, minus q, minus q is here, and you are putting a test charge small q here. You're putting a small q charge here. You want to bring the system in equilibrium. System should not experience any net force. Then what should be the magnitude of small q? So fine, let us start. What do we do? First, we take this force. This minus q is trying to repel this minus q, so it is what? It is force in this direction, and its value is 1 upon 4 pi epsilon naught qq upon r square. R is equal to what? It is the side length equal to a here. So it is this force that we have taken. It is what? It is this force. This force is equal to this force. Now similarly, look here that this minus q is also trying to repel it away, so it is equal to what? It is this force. It is this force, so it is trying to repel it away, and this force is here. Now this diagonal is also trying to repel it away. Okay, this is repelling it away, so this diagonal force is equal to this one. This time the diagonal length is equal to a root 2. So as previous calculation, a root 2 is squared, so it becomes 2a square. Now you see, what is the component analysis? The component analysis is being taken this way. First of all, you check that the component of this force along this direction will be taken at 45-degree angle. The component of this force along this direction, and similarly component of this force along this direction will be also taken at 45-degree angle. So it will be what? F cos 45, F cos 45. So F cos 45, F cos 45 is adding up. So this is what? It is equal to this force. Okay, when these two components will add in this direction, so it will make out this total force value, this total force value. It is what? Q upon 4 pi epsilon naught upon a square into root 2 cos 45, and this also q square upon 4 pi epsilon naught a square into cos 45. So both will add up, so here must be 2 also. 2 should also be here. Now what will happen? This force and this force is adding up, and this is already present in this direction. So what we have taken, we are finding first the component of this force along this direction, component of this force along this direction, plus the force that is already existing along this direction. So if it is the case, so these two terms are adding up, and this must be counterbalance. You have kept here what? You have kept here test charge small q. Minus q is experiencing net force equal to this much. Now this outward force must be balanced by an inward force, and that inward force is coming how? This inward force will come by this magnitude equal to of this magnitude. What is this magnitude? It is 1 upon 4 pi epsilon naught q upon a square, and this a distance is equal to what? It is a root 2 upon 2. That is what? It is equal to a by root 2. Okay, a by root 2. Now q cancels out, 1 upon 4 pi epsilon naught also cancels out. You simply simplify it, and then you find that the net value charge is coming equal to this much. Now next question. 6 identical charges small q is kept at the vertices of a regular hexagon. So these are what? 6 identical charges which are there at the vertices of a regular hexagon. Now see, a test charge q naught is kept at its center. So this is what it is. The test charge q naught is kept at its center. What is the net force experienced by it? So what is the situation? This capital Q will try to repel it down in this direction. What will be the force? 1 upon 4 pi epsilon naught q naught upon r square. q naught upon r square. So it is the force. And you see, in every regular hexagon, in case you join the center with any of the vertices, what you will find? You will find 6 equilateral triangle. So this diagonal length I am saying this length, it is equal to the side length itself. So whatever is the side length, that side length is numerically equal to its diagonal length also. So this is the force of repulsion, so it is counterbalanced by this force. It is the force of repulsion, it is counterbalanced by this force. It is the force of repulsion which is counterbalanced by this force. So the net force is what? It is 0. It is as per principle of superposition of charge. Now in the previous question, one extra charge q naught is added to one of the vertex. One extra charge. So earlier we have what? QQ charge placed on it. So we are having one extra charge. So because the charge is additive in nature, so we are having at one vertex 2q charge. Now this 2q can be separated by q and q both. Suppose because charge is additive, so let us have a separation. Now this q and q will add up and it will make equal to what? It is 2q value. And now previously the test charge q naught was kept here, and this time at the center 1 coulomb charge is placed. What is the net force experienced? To find the net force experienced by 1 coulomb charge placed at it. So it is very simple. I'll be just looking at this way. First, what we are trying to do, we are just looking, let us have this extra charge that you have kept, let it be separate. If it is separate, so because of this the system is not experiencing any force. But now look, this force value will be cancelled by this force value, will be cancelled by this force value, this force value will be cancelled by this force value. Let us have the analysis for this force value and this force value. This 2q charge is trying to repel it away. So 2q charge is repelling it with this force. This is the value of the force. Now this q is also trying to repel it away. This is this force value. Now what is the net force? The difference of these two forces we are taking, and the difference of these two forces is equal to this. Simple. Now let us continue for the next question. A charge capital Q is uniformly distributed on a circular ring of radius a capital R, and 1 coulomb charge is placed at its center. Then what is the net force experienced by it? This portion we have already done. You remember when I was discussing that how can we apply the Coulomb's law only to make the charges is a point charge. So पूरी ring को कई हिस्सों में cut किया था, and then the answer was coming 0. If you have not just gone through it, so you go through previous lecture series, you will find it is there. Now what will be the net force experienced by 1 coulomb charge if a small portion dl is cut from its circumference? So okay, very good question. We are having q charge given to this circumference. Dl is a portion which has been cut open. So let us see what is the pattern of distribution, because it is said that the ring is uniformly charged. So ring is uniformly charged, so the total charge is what? Charge divided by circumference. So it is charge stored per unit length. It is uniform distribution. तो पूरे circumference पे ये distribution pattern है, तो इस dl amount पर कितना charge है? So charge stored per unit length multiplied by length itself. So it is the charge that is missing from this portion. But had it been here, so the net force experienced by 1 coulomb charge could have been 0. अब क्या करते हैं? Now we again apply the principle of superposition. First we think like, चलो positive charge miss नहीं कर रहा था, the ring was not broken. And if the ring was not broken, so the net force experienced by this could have been 0. Now you bring minus q charge. So in case you bring minus q charge, so minus q and plus q will make out what? 0 charge value, and this is giving as if the circumference is cut by the amount length of dl and the charge amount equal to dq. तो क्या होगा कि पॉजिटिव चार्ज की प्रेजेंस और नेगेटिव चार्ज की प्रेजेंस एक दूसरे से एक्सर्टेड फोर्सेस के मैग्नीट्यूड को चेंज नहीं करेगी. ये टूल ऑपरेशन पार्ट है सुपरपोजिशन प्रिंसिपल का. तो ठीक है, अगर पूरा पॉजिटिव चार्ज रहता तो 0 फोर्स नेट बनाता, पर अभी तो पूरा चार्ज नहीं है, माइनस भी मौजूद है, तो माइनस टोटल प्लस की वजह से तो 0 चार्ज, पर माइनस की वजह से दिस 1 कूलम चार्ज विल बी अट्रैक्टेड दिस साइड, एंड देन द फोर्स वैल्यू विल बी 1/4 pi epsilon naught dq into 1 q1 q2 upon r square. R is the radius, it is the net value of the force that this 1 coulomb charge is experiencing because of what? A circumference which is having a slight cut placed on its circumference. Next question. 3-point charges plus 2 microcoulomb, minus 3 microcoulomb and minus 3 microcoulomb are kept at the vertices ABC respectively of an equilateral triangle of side length 20 centimeter as shown in the figure. Look, it is 2 microcoulomb plus 2 microcoulomb minus 3 microcoulomb minus 3 microcoulomb. They are placed at the vertices of an equilateral triangle having side length equal to 20 centimeter. What should be the sign and magnitude of the charge to be placed at the midpoint? यहाँ पर कौन सा चार्ज रखा जाए? यहाँ पर कौन सा चार्ज रखा जाए so that the charge at A remains in equilibrium, कि यहाँ पर ये system comes in equilibrium. So look, first part we are taking, this charge is being attracted, this plus 2 microcoulomb is being attracted by minus 3 microcoulomb charge in this direction. So the value of the force that is exerted at A because of charge placed at B, so it is equal to 1/4 pi epsilon naught, that is k, q1 q2 upon r square. R is what? 20 centimeter, that is 0.2 meter. It was in microcoulomb, so this is in microcoulomb, this is in microcoulomb, so this 10 to the power minus 6, 10 to the power minus 6 adds up to become 10 to the power minus 12. So this is what the value of the FB. We solve FB and FB value is coming equal to, say, this one. After calculation you find it this. Now you see, what about FC? Previously when FB we were calculating, तो 2 microcoulomb minus 3 microcoulomb were the charges. अगर FC देखें तो भी वही charge value, वही distance value, तो वही force value भी. So FB and FC both are equal and it is equal to 1.35 Newton. Now what is the net force? What is the net force? So net force, because these two forces are acting at 60-degree angle, these two forces are acting at 60-degree angle. So net force is equal to what? Under root p square plus q square plus 2pq cos 60. You solve it. Now this is going to be the net force that is the resultant of FB and FC. ये नीचे की ओर एक्ट कर रहे हैं. अब हम चाहते हैं सिस्टम इक्विलिब्रियम में रहे. सिस्टम इक्विलिब्रियम में कब होगा? जब इस पर कोई नेट फोर्स नहीं होगा. तो यहाँ से एक अपवर्ड फोर्स होना चाहिए जो इन दोनों फोर्सेस को काउंटर बैलेंस कर दे. तो अगर वो काउंटर बैलेंस करना चाहते हैं, सो व्हाट विल बी लुकिंग, इट इज k q1 q2 अपॉन x स्क्वायर. सो k q नॉट into 2 microcoulomb, this is q1 q2 upon this square. So this distance is 20, this distance is 10, so you can find out by Pythagoras theorem what can be this distance. It is 10 root 3 centimeter. It is 20, it is 10, so it will be 10 root 3. So अब यहाँ से जो फोर्स लगेगा, यहाँ से ऊपर को जो फोर्स लगेगा, it will be 1/4 pi epsilon naught q1 is equal to q naught, q2 is equal to 2 microcoulomb अपॉन आर स्क्वायर, आर इज व्हाट, इट इज 10√3 होल स्क्वायर। यहाँ पर देखना हमने इनको x1 मान लिया है। अगर हमने x1 माना सो इट इज √x1 स्क्वायर प्लस x1 स्क्वायर प्लस x1 स्क्वायर प्लस 2x1 स्क्वायर cos 60 इसकी वैल्यू 1/2, तो ये हो गया √3x1 स्क्वायर यानी x1√3। Now we'll put the value of x1 as what? This. We can find out what is the value of q0. Is it right? That's it for today.